In this video, we're going to talk about the two different kinds of uncertainty, and we're going to learn how to differentiate between the two of them. Aleatory uncertainty is uncertainty that is naturally occurring. It is true randomness, if you like, and it is something that you cannot reduce in any way. It is out there, there's nothing you can do about it. Epistemic uncertainty, on the other hand, is due to lack of knowledge about something. It is not knowing something because you haven't measured it yet. And it is, in principle at least, something that you can reduce. It's uncertainty that you can reduce if you're willing to pay the price. That is, if you are willing to run an experiment that will measure the thing that you don't know anything about. I would like you now to consider a specific example, the example of a bevel gear being spit out of a manufacturing process. So take a gear coming out of this manufacturing process and use an electron microscope to measure or to visualize its microstructure at a specific point. Let's say you do this and you see the picture that is shown on the screen. Now if you do it again on the second bevel gear coming out of your manufacturing process, you are of course going to see a different picture. And if you do it for a third time, you will see a different picture. And if you do it for a fourth time, you will see a different picture. So in that sense, your uncertainty about the microstructure of the bevel gear is an example of aleatory uncertainty. It is true randomness. Every time you measure a different gear, you see a different picture. But take now a specific gear, a gear that you have in front of you, just one gear, and measure its microstructure at a specific point. You're going to see a picture just like the one shown on the screen, but if you measure again, are you going to see a different picture or are you going to see the same picture? You are of course going to see the same picture. And if you measure it for a third time, you will see the same picture. That is, if you measure multiple times the same gear at the same point, you will keep seeing the same microstructure. So in that sense, your uncertainty about the microstructure is an example of epistemic uncertainty. The microstructure of a specific gear is something very well defined, something that exists independently of any manufacturing process, but you just don't know it. But once you measure it, it has disappeared. All uncertainty has disappeared. You know exactly what the microstructure is. So using this example, you see that whether you have aleatory uncertainty or epistemic uncertainty, where you have true randomness or uncertainty due to lack of knowledge, depends on the context. So it depends on what exactly you're trying to do, what are the variables of your problem, and where do you draw the boundaries for your analysis. And at the end of the day, at least in this class, when we try to describe our uncertainty about certain physical quantities, we are not going to worry about whether it is aleatory or epistemic, because both these types of uncertainty are quantified in exactly the same way. We quantify them using probability theory. So we're going to be writing expressions like the ones you see right here on the screen, which are read, what is the probability that we're going to have a specific microstructure given everything we know right now. And if you have aleatory uncertainty, then this probability would correspond to true randomness, to the frequency, if you like, of observing with which you're observing specific microstructure characteristics in bevel gears that are coming out of your manufacturing process. And if the context is different and you're looking at a specific gear, it will be your state of knowledge about the microstructure of that specific gear, conditioned on everything you have, all the data that you have collected about it at any given point in time.